All right, so we're now today gonna build the second quadrant of the unit circle. So again, I'm going to build those three triangles, the 30 degree, the 45, and the 60. So I'm gonna go ahead and draw a coordinate system for the 30, and then I'll do so for the other triangles. So let's just start out with your simple coordinate here, quadrant here. So let's just remember that when we're talking about the second quadrant, that's when the x values are going to be negative and the y values are positive, right? Because we're in this quadrant, notice how the x values are this way, so they're negative. Y values are still in the positive region because it's in the upper region. So in this case, here's my coordinate system. And we've learned before that this is 0 degrees, 90 degrees, and 180, and then 270. And back to 360. Well, hopefully at this point now you're starting to connect the dots why we were learning it from, this circular motion, right? Because we are going to now, we've now placed a circle inside this coordinate system. And when you go all around the circle, you make a 360, okay? So like I said, we're not going to draw the circle this time, but just imagine if you had a circle and a triangle inscribed just like yesterday. So we're going to draw ourselves that 30-degree triangle, but now in the second quadrant. So in the second quadrant here, I have, 30 degrees. And I want to figure out what is this point right here. What is this point that will hit my circle? So remember that this tip point will intersect the circle that it's inscribed in. So I want to know what that point is. So I need to figure out my x and my y. So yesterday we said that the hypotenuse for the triangle will always be 1 because it's inscribed in a circle that has a unit of 1. And so if you remember from yesterday, the 30-degree triangle is using the properties. We got the short piece to be 1/2, right? And then this long piece here, we're using the property, would be the, actually, you know what? Let's go calculate that again. Let's practice this. So if this is 30 degrees, right, and this is 60 degrees, we have a right triangle. Remember, the short side is called x, and then the hypotenuse is double the short side, so 2 times x. And then this longer side here is going to be x times the square root of 3. So notice that if I know that my short side here is 1/2, that's my x value. So if x is 1/2, then this 1/2 is going to be multiplied by the square root of 3. Well, if I work that out, isn't this here like a fraction? So I can put this over a fraction if I put it over 1. And then I would multiply those two. So 1 times the square root of 3 is the square root of 3. For the top. And the bottom here, if you multiply the bottom, 2 times 1 is 2. So this here, our long piece, is the square root of 3 over 2. But here's the thing. So I found my x value here, right? Because this is on the x-axis, this is my x value. And this is on the y-axis, the height of the triangle, so this is my y value. So I found those trig values, which is great. But the thing I need to consider is that we are in the second quadrant. And the second quadrant, the y is positive, but the x here is a negative. So this value right here, it's a negative. And that means all our x values that we're going to be finding are negative. So we found our coordinate system. Not our coordinate system, our coordinate. And so we have that piece, so keep that in mind. We're going to keep that. And then I also want to answer this question of, what is the terminal angle? So remember, the terminal angle is the angle that is from this side, the initial side starts here, where, x is 0 degrees. But then when you move on to this side, where the hypotenuse is, this would be the terminal angle. So I want to know, what is the angle right here, right? So in this case, the terminal angle, well, if this straight line is 180 and this triangle is 30 degrees, can I just subtract these two and find this terminal angle? Yeah, I can. So I can take 180 and subtract it by 30 degrees. And so that gives me 150. And so in this case, my terminal angle is 150 degrees. This is actually the angle that's supposed to be here in reference to this. So the terminal angle is what you are going to be writing for each triangle. And so our terminal angle is 150. So we're going to keep this, the terminal angle, and we're going to keep the coordinate. So now we're going to build our next triangle, so the 45-degree triangle. Okay, so here I have our 45-degree triangle, and remember we are trying to find that terminal angle. So the terminal angle here from the initial side. So what is this angle here? And then our coordinate that sits here. So again, remember we have to consider that our x value is going to be negative. So just kind of a, jogging the memories. Remember our radius here is going to be 1 because the unit circle has a radius of 1. And then if I want to find the other two sides, well, I used the triangle properties for a 45-degree last time to figure that out. So I'll just quickly do that again. But basically, a 45-degree triangle is isosceles. So, if you have the length of one side, then the other length is going to be the same because the angles are the same. And then the hypotenuse, well, the hypotenuse is just x times the square root of 2. So from there, if I know that the hypotenuse is 1, then I could also just solve for the x value, right? So what I can do is take my hypotenuse and set that equal to x square root of 2, right? This is going to be equal to this so that I can solve for x. So if I want to solve for x, all I got to do is divide the square root of 2 over. So we did this last time in one of the journals. So I would have the square root of 2 here. And so now, let me see if I can move this over so that's not in the way so much. Oops. Or maybe I can shrink this a little bit. Yeah, that's a little better. So in this case, I would have to multiply the top and bottom to get top and bottom by the square root of 2 to get rid of the 2 in the bottom. So if I were to do that, I'm going to write it over here. I would have the square root of 2 in the top, and the bottom here would be a 2, and so that would equal my x. So square root of 2 times 1 is the square root of 2. Square root of 2 times the square root of 2 is just 2. And so x here is the square root of 2. Well, x is one of the sides for the 45-degree triangle, so it's also the other side. So both of these are the square root of 2 over 2. However, the thing is that this piece here is going to be a negative value because it's our x value. All our x's here are negatives. So we have the negative square root of 2 over 2 and a positive square root over 2 for the y. And so now we have our coordinate. Let's go ahead and find our terminal angle. So our terminal angle here, we're doing it just like before. Remember, this here is a straight line. You know that this side here is 45. So to figure out this side, well, that's just the supplementary angle, right, to 45. So if I add this angle with this angle, I should get 180. So I have 180 minus 45, and that would give me 135. And so this angle, this terminal angle here is 135 degrees. And so, like again, that I said, keep this angle and this coordinate. We're going to use it here in a minute. But we're going to do one more triangle. We're missing the 60-degree triangle. So let's try that. All right, so I have our last triangle here. And again, we are going to be finding that terminal side of this angle, this triangle. So I need to figure out what this angle is, and I need to figure out what the coordinate here is. And our radius is 1, just like last time. So the thing is, this is the 60-degree side, whereas before we had just solved the 30-degree, right? So a moment ago we solved the 30-degree. It was 30 degrees on this side, and it was 1 here, and then I believe the short side was 1/2. Oops, sorry, I meant to get a pen. 1/2, and then the long side was the square root of 3 over 2. So the first triangle that I drew in this video was this one here on that coordinate system, right? Well, because a 30-degree triangle also has a 60-degree on the other side of it, well, we can just pivot our perspective to figure out this side here. So like what I mean is, notice how the 60-degree here, the short side is 1/2, and here's our short side. So this short side here is 1/2. And it's negative 1/2 since we're on the x that's on the second quadrant. And so then for our y value, this tall part here, well, that has to be this tall part here because the 30-degree would be sitting right there on this triangle. So this 30-degree has a side length of square root of 3 over 2. Square root of 3 over 2. And so now I have my x value and my y value. If you notice here, the 60-degree versus the 30-degree, their x and y values are flipped. They're the exact same values, only they're flipped. So it's like the x switched with the y switched with the x's. And so now I have my coordinate, my terminal angle. Well, what's 180 minus 60? Let's do the math. If you subtract 180 from 60, you get 120 degrees. So this is 120 degrees. And so remember, our terminal angle allows us to locate which quadrant we're in, right? So if I was 120 degrees positive, we would start on this x-axis, the positive x-axis, and we would turn until we're 120 degrees and land in the second quadrant. That's why I need you guys to find the terminal side angle, because that allows you to see that, oh, you're in the second quadrant, not the first quadrant. Because if you were to use 60 degrees, you would be starting at the 0 and going 60 degrees. Well, that's going to be somewhere in between 0 and 90, which is the first quadrant, which is no good. You want the second quadrant. All right, so let's put this all together in our next slide where we're building the unit circle with quadrant 1 and our new information, quadrant 2. Okay. So here's my unit circle fully blanked, and what I'm going to do is add in those triangles that we had before, but I'm not going to draw the triangle. I'm actually just going to draw the triangle's hypotenuse. So what I mean is from yesterday, quadrant 1, so we're going to start off with our quadrant 1. We had the 30-degree, so this is my 30-degree angle, and then we had the 45-degree angle. Then we had the 60-degree angle, and then it goes up to 90 on this side. So I'm going to go ahead and fill these out from yesterday. So we got the coordinate here because it hits the x-axis, right? Our y value here is 0, but our x value here is 1 because the radius of this circle is 1, if you remember. And so that point right there is going to be hitting the x-axis at 1, and so that's why that value is 1. And when we're doing the 30-degree triangle, that is going to be the square root of 3 for my x value over 2, and then 1/2 for my y value. And then 45 is my favorite because 45, both of their values is square root of 2 over 2. It's so easy to remember. Then this one here, if I know what 30 is, basically to get 60, all I got to do is switch them. So this one will be 1/2, this one will be the square root of 3 over 2. I don't like how I wrote that. Let me fix that. Square root of 3 over 2. And then at the very top right here, at 90, because the circumference of this, not the circumference, the radius of this is 1. So if this hits 1 on the y-axis, that means my y value is 1. But my x value here, notice how it's at 0. So I have 0 for my x value. And so yesterday we learned that if I want to know my cosine and my sine using the coordinates, the x value is cosine, the y value is sine. And that all goes back to the reason why the reason why that is true, this is true, is because the radius is 1. Now let's put in together what we've learned in the second quadrant. So the second quadrant, we started out down here with the 30 degree. And so 30 degrees, we found out that the terminal angle from here to here was 150 because it was just taking that 180 and subtracting 30 degrees. And then our next angle here is going to be very similar to the 45-degree angle on the first quadrant, only this is now in the second quadrant, so we took 180 subtracted by 45. That gives you 135 degrees. And then last but not least, our 60-degree triangle that's in the second quadrant. If you take 180 subtracted by 60, you get 120 degrees. And so now we just need to put in those quadrants, the coordinates that we had before. So the coordinate for, let's say, the first one here that we found earlier for the 150 was the square root of 3 over 2, 1/2. But the x value was a negative, right? I want you to take a notice of this because it's really interesting here. These 2 points, the 30 degree in the first quadrant and the second quadrant, the 150 degree. Notice how they are exactly, like almost exactly the same, right? The x values are pretty much matching up. The y values are the same values. The only difference is because we are in the second quadrant, it's a negative value for the x, whereas the first quadrant, the x value is a positive. So you can already tell, like, if I was at the 135 terminal side, well, that came from the 45 degrees. So I'm basically going to copy and paste this over, but make the x value here a negative. And then we have our last one here, the 120, which is associated to the 60 degree triangle. But it has a negative 1/2 for the x value, and the y value is still the same. I don't have to find the 90 degree because I've already found it, but I do have to find the 180 degree. But using that same principle, the 180 degree is like the same side as the 0 degree, right? This 0 degree. So in this case, if I were to use the same concept, wouldn't this be negative 1, 0, right? The x value would be a negative and the y value would just stay the same. Right, because if you look at this point right here, because the radius of this circle is 1, if you're on the second quadrant, this is not a positive 1. This is a negative 1 because it's in the negative direction. So if I were to ask you, what's the point here? You would say negative 1 for x, and then this is on the y value for 0. So negative 1, 0. And so now we have the first quadrant, and now we have the second quadrant. So tomorrow we're going to talk about the third and the fourth, because now hopefully you should recognize that this quadrant circle is going to be recycling these numbers. The only numbers you see on a unit circle is 0, 1, 1/2, square root of 3 over 2, and the square root of 2 over 2. Those are the only numbers you see. The only difference is they get switched around and the signs change depending on what quadrant you're in. But that's all the numbers that you see. Okay, so until next time. Bye, guys.